Swayam Prabha. Digital India. Educated India.
Hello everyone, and welcome to the last discussion of this course, that is the limitations of GIS. As we know that we have discussed that GIS can do this and that, but one should not oversell the GIS, because GIS is one of the platforms which can solve lot of problems, but nothing is universal in this world. So, GIS too is having limitations, and before we close this course, I thought that I will discuss this part. We must know the limitations of GIS. If we do not know, for example, if we know that a car cannot fly, it would be better. Otherwise, if we increase the speed of car so much that we cannot control. So, the same way we should not propagate that GIS can solve each and every problem of the earth, not at all. GIS is also having limitations. GIS is also not a universal tool. It is a platform to handle spatial data which is coming from variety of sources, and it is allowing us to organize in an efficient manner, analyze it, and then create models, final outputs. But these things are having limitations. Another thing is, if somebody has to do a small work, a organization for example, and if they find that the solution which is coming proposed from GIS is expensive, then they will not resort. So, one of the things which is said about the among the limitations of GIS, that GIS solutions sometimes are expensive. And whereas people find that atlas or maps or online maps are cheaper and easy to handle. So, initially a organization may face this problem, that is the expensive. Now, sometimes also requires too much data. If an organization is just starting using GIS, then everything is required. You require software, you require hardware, you require data. For a initially for a very small map or data output or analysis. So, that organization may not support that one. So, requires too much data sometimes, and that too in digital format, and you know digital things are expensive. For example, a survey of India topo sheets, if you buy in a print form, may cost only 100 rupees, but if you buy in a digital form, that may cost 30,000 rupees. So, there is a large difference between analog product and a digital product, because digital product can be copied easily, therefore, they have added so much cost. So, this must be taken care that if a organization would like to start using GIS for initially small work, then they may face some problems. So, this is we can consider under this limitations of GIS. Further, as you know, by definition, GIS is a computer based information system. So, you require computers all the time. Now, computers are becoming very common, but on a very standard PC or a laptop, you may not be able to run good GIS software. So, you require like a workstation or very expensive powerful laptop to run a GIS software, a good GIS software. So, that means it is computer intensive, and ultimately it basically cost, and many times it can prove expensive for a organization who, again I am saying that who requires just small work to be done initially. Further, we know that it requires big storage. It requires storing of the raw data, it requires the storage of process data and final outputs. Another problem which GIS faces sometimes is GIS spatial databases are software dependent. That means that I have created a database on a particular GIS platform. Now I want to use the same database on the other GIS software platform, and there may be some difficulty. So, converting from one database to another is a challenging. Therefore, that is why it is mentioned that the spatial databases, GIS spatial databases are generally software dependent, and therefore their export and imports are very limited. It is not just like that you are having a GIS database and X software you start tomorrow using in the Y software. It will not work, especially the projects which I have created and saved will not work at all with other software. Sometimes even they do not work with the same company's software of having different versions. So, one has to be aware about this limitation of GIS as well. Sometimes it is said that the GIS solutions are too slow. Initially, yes, because if an organization is just entering in this domain, then for them it requires lot of time. They have to arrange hardware, software, persons, data, then only solutions will start coming. So, initially sometimes the GIS solutions are too slow. Again, since we are using digital data, and nowadays these issues, especially about copyright and distribution issues, are becoming complex. Because digital data can be copied from here to there, and many times we may landed with these complications. So, that those issues are also creating in some way limitations for GIS. Now, this is another limitation, that if I have created a 3D perspective view which I can rotate on my system, but when I create a output as a hard output, a hard copy in a form of printout, then that flexibility or facility is gone, and then it becomes difficult for decision makers to show. So, that means every time the computer system along with projection system has to be carried. So, many times output maps results can only be viewed on computer system. This part we have just discussed in the previous discussion, that errors propagation can lead to very erroneous results. So, that can also be one of the limitations of GIS. Now, another part which I would like to discuss, which I have been mentioning here and there in my previous discussions, lectures, about the GIS rules. Again, you will not find in any book as I am going to discuss. GIS rules, the number one, there is no scale of digital data. Many people initially may not agree with this statement. But what I say, as long as the data inside the computer in digital form, there is no scale. But once the data is projected or printed on a map, the scale is frozen. Therefore, if we say that the digital data do not have any scale, it is absolutely correct. However, the digital data which I am having inside my GIS database may have come from a data source which had the scale or resolution, spatial resolution. But as long as it is inside my computer in form of real digital form, not a scanned one, then it will not have any scale. So, that means the same map I can print on A0 size and same map I can print on A4 size, and in these two different outputs will have different scales. So, it proves the point that the digital data do not have any scale. Now, another point is that colors do not have any meaning in GIS. Generally, we should follow some convention of colors. I gave the example like for forest, we should use green color for depicting forest. Sometimes we use for agricultural land, we use the light green color or yellow color for that. But using red color for a forest no one would appreciate. However, colors do not have any meaning. What meaning is that the value of the object feature, that matters a lot, not the colors, because colors are only on the screen, because they are being used before there is a palette which is saying that this color and this value should we use this color. So, we must take care about the values rather than colors. Colors we can change any time, but values we should not change, we cannot change. Third point, we have mentioned many times that error propagates in GIS. Hence, errors should be checked at every stage of processing. After each and every operation in GIS, one should check for errors. If found, correct it, then go to the next step. The fourth rule of GIS is that 0 is a value in GIS. 0 does not mean no data. And we had a separate complete discussion on no data. So, concept on no data came little later, though GIS was existing before that. So, this 0 is a value in GIS, and especially in digital elevation models which are somebody is working in the coastal area. There they may face problem if they do not have this facility of no data in their software to handle. Because 0 means it is close to the sea, and minus values can also have. But if I do not have any survey points or anything, then how I will represent? I cannot represent as 0. I have to have some value which is declared to the system that whenever you encounter this value, just ignore in analysis. So, 0 is a value in GIS, 0 does not mean no data. Now, the fifth rule of GIS that straight lines should not be digitized. Only coordinates of two endpoints are digitized and connected. Because if you start digitizing a straight line, you are not keeping a line segment, but you are creating a polyline, and we suppose should not have been there. So, a straight line should not be digitized. Only coordinates of that straight line, two end members, these nodes should be digitized and connected later on. The sixth rule, never digitize a line, polyline or polygon twice, because no person can digitize the line 2-3 times in the same way or even 2 times in the same way, and therefore, you will introduce errors. So, whenever doing a digitization, take care that you digitize only once, otherwise you would create artifacts and ultimately you would end up with some errors. Seventh is do not completely depend on the export and import tools available in GIS, because they may introduce errors. Conversion from one format to another, there may be introduction of errors, because these conversions may not be 100% transparent. And therefore, if I export or import, these may change coordinates of data sets because of the precision setting. So, while doing this thing, exporting data or importing data into GIS, we must take care about that. So, after the export, I should check whether it has correctly exported, and if I am importing from somewhere, I should again check whether there is any difference between the original, because this export import is doing nothing but the change in format sometimes. So, and these are the 7 rules of GIS. I have as mentioned that these are not part of, you will not find a part of any book, but very important to remember. Now, the other part of this discussion is, and this is the last basically, is that the GIS, the term is still meaningful, because it was introduced somewhere in 1965 by Tomlinson, and since then it was being used, but at the same time people are bringing new terms. So, the question comes whether the term GIS is still meaningful. Roger Tomlinson, which is also called the father of GIS, and we paid a tribute and discussed in the very first lecture when we discussed what is GIS. So, Roger Tomlinson wrote to share his thoughts on the recent discussion regarding the term geospatial. And he wrote that the great discoveries and improvements invariably involve the cooperation of many minds. I may be given credit for having blazed the trail of GIS, but when I look at the subsequent development, I feel the credit is due to others rather than just myself. This is his feeling, the inventor. But what others are doing, they are bringing many names and trying to forget his contributions. Like instead of calling GIS, people have started calling computer mapping, land information system, geoinformation systems, computer graphics, spatial information systems, geoengineering, geomatics engineering, geospatial engineering, and topographic systems. If you start looking one by one about these terms which are being used instead of GIS, you would find that they are all talking about GIS, that is Geographic Information System. So, what is wrong if we use the word GIS rather than these other fancy terms? And one more term which is becoming quite popular, geoinformatics. So, why we would not like to use word GIS rather than all these words? There is no explanation. What is lacking in GIS which these are supporting? If I say topographic system, that means it is only handling the topographic data, but GIS is not only for topographic data handling. And if I say geoinfo system, again ultimately I am talking about GIS. So, also some other terms like computer aided design, conceptual surface analysis, urban planning systems, hydroinformatics systems, graphically referenced data storage and retrieval systems, land use and natural resources systems, interactive composites mapping systems, etc. So, these new terms are coming. Instead of using word GIS, they are all bringing confusion in this field, which is not good. There is nothing wrong using term GIS. It is popular and it encompasses all those works or ideas or aims which we would like to have. Some have different shades of meaning, because all these terms which I have just mentioned, they are having some other purpose, but the overall term geographic information systems serve us well, and it has clear meaning, uses real words rather than manufactured words, and has a relatively long history. Tens of millions of dollars have been spent successfully putting it into the public mind. The GIS now is recognized worldwide. If I say topographic information system or hydroinformatics system, next question would be by anybody who hear first time, what is that? Oh, you are talking GIS application in hydrology. So, since I am working in hydrology, I call as hydroinformatics. No, you should use the word GIS and its application in hydrology, no problem. So, the strength of the term comes from the fundamentals, that is the geographic, not geography, as the term is not going to go away. And it has been used for hundreds, some would say thousands of years, and it is not new. It means description of the earth when we say geographic, and also it carries the meaning that objects are having geographic coordinates. That is what we do basically in GIS. Geographical, some people also use geographical data, are those used to describe the earth that is we handle. So, the most appropriate term even today is geographic information systems. So, they may be gathered using various sophisticated techniques, that ground survey, air photo interpretation, GPS or GNSS, photogrammetry, remote sensing, image analysis, digital image processing, population census, etc. And the results of all this is geographical data. So, uses of GIS, no change, the primary three, that manage data, analyze data and communicate information. So, the roles of GIS have not changed. So, why to change the name? However, the application of GIS may be in different domains. That is the purpose basically, because the data itself is coming from variety of sources. So, applications can be also variety of domains. So, no change because of primary managed data, analyze data and communicate information GIS, but relative importance shifting. New things are getting added, like I mentioned about digitization. Now, using typical digitizer, that flatbed digitizer is not used now, because now we are having very high resolution screens and mouse, and we use that one. So, sometimes the importance keeps shifting. Implementation technology changing. Again the technology or hardware sometimes changing. Earlier when we did not have the reliable this GNSS system, we used to rely for GCPs for some other sources. So, definitely those things are changing. Now, some thought about the this changing emphasis and future. So, what we are from data to analysis, that is the aim. So, here special 5% analysis in the past, because we were spending more time for data conversion from analog to digital, organizing data, making compatible to GIS software platform and so on. And then we used to spend lot of time for 10 to roughly 10 to 15%, this is a word average, about the tagging the attribute data with the spatial objects. Now, this triangle has inverted with time, that now we spend most of the time in the analysis, because the data is available in GIS compatible format, in digital format quite easily. For example, digital elevation models, 20 years back we did not have so many. Now, you are having from 1 kilometer to 20 meter or 15 or 12.5 meter freely available. And also sometimes you do not have to attribute tagging or typing, because data is already available. So, the technology has improved, our approach has improved. So, this is what is the present and future is going to be of changing emphasis from data to analysis. Earlier the emphasis was to organize the data, the time it took to consume or the energy it used to consume was only for the data organization. And when, for example, somebody is doing his say MTech dissertation, now he is to spend lot of time for organizing the first part, and then when he is approaching the last date of submission, he left only few weeks. So, he would spend little bit time on this analysis. Now, since day one, he is having lot of data available in digital format, and not only digital format, GIS compatible format. Now, this changing emphasis is also now shifting from descriptive to simulation and modeling. That is the ultimate aim of GIS. Some simulations I have shown, some models I have also discussed. So, here where we used to believe that the picture worth 1,000 words. Now, we are having visual simulations and virtual reality. So, emphasis is completely changing, it will further change, and we are going from our own GIS system to a sort of internet based GIS system. Best example is Google Earth, Google Maps. The data is not in our machines, the data is somewhere else on cloud or servers or other places. We are just users. So, that way we do not have to spend much time of creating our own data sets. The data would be available, only we require how to analyze the data for a particular study. So, earlier the maps, diagrams, how it is, and these were the main emphasis. Now, the real time display, because the data is increasing, large volumes of remote sensing data available. Earlier we used to buy the data, now a lot of free data from various satellites, various sensors of varied spatial resolution is available on almost daily basis. So, we are changing to the real time display. Further, web portals serve static data sets. This is what they have been doing in past, but now we are going for web portal serves continuous sensor driven data. The data is being scanned by the satellite and it is becoming available or will become available in future on the web portals very easily. So, from iconic models, scaled down representation of the real world which was the past, the symbolic model based on the logical relationship in mathematical or statistical form. Now, the tools or techniques which are becoming more or getting implementation into GIS like AI, machine learning, artificial intelligence or ANN, artificial neural network, all those things are also getting percolated into GIS and in that way the future is very bright. Now, here this is the example that how a digital elevation model, if we are having the SAR interferometry data for example or stereo data, it can be created like this if things are changing on the ground. So, in many natural disaster conditions, these can really help us to find out what is really happening real time or maybe population density or maybe some other things which are changing with time, forest fire and other things, they are all changing time. We want in many times information based on satellite and many times in a day. So, there we can employ this thing. Applications, real time traffic information, transportation planning, taxi cab location, this is already implemented, retail store location and so on and so forth. So, all these things are going on and lot of new developments are taking place for the GIS in this field of GIS. Changing further, we are changing emphasis from 2D descriptive to 3D or 4D interaction. That means we are adding time, how things are changing. So, past 2D flat maps display, future is effective 3D visualization. Also 4D incorporation of time, time has come for the time. That is most important thing because now it is possible, lot of data is available. So, we can detect the changes which might be happening hourly, which might be happening on daily basis or in a yearly basis. So, the time is getting added into the GIS. Earlier it was not possible, we were just restricted to 2D display, flat map display. Now, we are talking about 3D displays, 3D simulation, 3D visualization along with the time changing and maybe in future 5th, 5th or 7th dimension incorporating touch, pressure, texture, temperature, sound, smell in modeling, simulation, environment, etc. But these things will also might come in future. So, not only adding the 4th dimension that is time, but adding few more things, pressure, texture, like on the touch screens we are using this technique. So, maybe in future in others. So, this new word feelies becomes reality and users as participants. So, users will be the participants, they will not be simple users and users of all this development may be from research background, professionals, the public and of course, participatory GIS. That means this is the GIS is going to come and we also use the term like crowdsourcing. So, lot of this crowdsourcing. So, lot of crowdsourcing is becoming anyway reality. So, that is leading us to a participatory GIS. In the past, in the again changing emphasis out of this word, the GIS applied to the planet Earth, but now we are going away from that. And not only this, but we are going far also the other parts like Mars, Moon and other spheres also. So, other planets we are trying to cover. Now, few words on the future of GIS, that if I really knew, would I still be there here. That means it is very difficult to guess the development which is taking place in computer science, development which is taking place in communication and also in the satellite based remote sensing, also in the positional improvements through GNSS systems, it is very difficult to predict what is going to be the future. But some things we have already discussed, that what is the future. But this last is, if I really knew, would I still be here? No, I do not know, but still I am here. With this, thank you very much, and I really enjoyed with you in this course, and I hope that you would also enjoy this course. So, with this, thank you very much. Bye bye.